We've looked so far at trig functions of angles that happen where all the sides are positive, where you're really in the first quadrant. Today we're going to extend that to looking at trig functions of angles that are anywhere in the coordinate plane. And it turns out you can do that just by looking at the angle that your angle makes with the x-axis. So we're going to do some examples so you can see what that looks like. So in other words, let's say we have an angle theta. We've drawn that there. It's in standard position. And some point P with coordinates x, y as a point on that terminal side of theta. First of all, we can find the distance from P to the origin, which is your hypotenuse, just by using the Pythagorean theorem. So by doing x squared plus y squared equals r squared. And then, if we look at our triangle, we can kind of label it here. If our x coordinate is x, then it must be x along the bottom and y up the side. If you've taken physics, this probably looks familiar, but don't tune out because there are a few little differences as we go. Okay, so then the sine must be opposite, which is y, over hypotenuse, which is r. Cosine must be adjacent over hypotenuse, and tangent is opposite over adjacent. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. So let's do a couple examples. So these should not involve using any kind of trig functions on your calculator because we're finding exact values. So in this example, we're going to look at the point P is 9, negative 12. So I'm going to start by sketching in that point and drawing in the angle. So the point 9, negative 12 should be roughly down here somewhere. We don't have to be too careful about the scale. So I'm going to label my sides here. So if it's 9, negative 12, first I'm going to draw my triangle to the x-axis. Like one side has to be the x-axis, not the y-axis. So here's my right angle. So my x-coordinate is here is 9. My y-coordinate's negative 12. This is where I think you're going to differ from physics in that we carry those negatives along when we're in math. So we got to find r. So we'll do some Pythagorean theorem. So 9 squared plus negative 12 squared equals r squared. Works out that r is equal to 15. Be careful with your parentheses around your negative if you're squaring in your calculator. Okay, so this is 15. I should note r is always, always, always positive. Okay, so just to reiterate, x is 9, y is negative 12, r is 15. So sine theta, opposite, negative 12 over hypotenuse, 15. We can simplify that down to negative 4/5. Cosine theta, 9/15, adjacent over hypotenuse, simplifies to 3/5. Tangent theta, negative 12/9, simplifies down to negative 4/3. So for the first time, we're seeing some sines and tangents that are negative. That is not a mistake. It happens. As we start thinking about these things as functions, we'll see that more and more often. All right, so now for the rest of them, we just flip some things. So cosecant is the reciprocal of sine, so that's negative 5/4. Secant would be 5/3, reciprocal of cosine, and cotangent is negative 3/4. All right, one more example here. So let's say we have the point negative 6, negative 2. So let's plot it first. So negative 6, negative 2 is over here somewhere. I'm going to draw in my triangle with the x-axis as one side. So then if A is negative 6, so negative 6, and then negative 2. So if you're going left, it's negative. If you're going down, it's negative. And so then for r squared, we'll do negative 2 squared plus negative 6 squared equals r squared. So r equals 2 radical 10. As soon as we see that radical showing up, we know we're going to probably have to rationalize at some point. Okay, so to reiterate, x is negative 6, y is negative 2, r is 2 radical 10. All right, so the sine is negative 2 over 2 radical 10. We'll go ahead and simplify that first just to negative 1 over radical 10 because I can divide the 2's. But I think before I rationalize, I'll go ahead and flip it for cosecant. So that's going to just be negative root 10. Then I'll rationalize that sign. So if I multiply by root 10 over root 10, I'm out of room. I'm going to have negative root 10 over 10. Okay, so cosine. Cosine is going to be negative 6 over 2 root 10. So I can simplify between the 6 and the 2 to have negative 3 over root 10, which makes secant negative root 10 over 3. And then I'll rationalize back for cosine. So times root 10 over root 10 is negative 3 root 10 all over 10. Tangent, I'm finally out of the radicals, is negative 2 over negative 6, and that's 1/3, which means that cotangent must be 3.